Hello and welcome students. See, in today's lecture we are going to do linear programming problems. This topic is very simple, and for your 12th standard syllabus, what you need is that makes this topic more simpler. So let us start with this. See, in this topic, students, the basic requirement that you have is you have the basic requirement of straight lines, the knowledge of linear equations. See, these are the following things that you will need. You will need linear equation. You need to know what is a linear equation in X and Y. Then you need to know the idea of linear inequation in X and Y. See, these are the things that are prerequisite. That is, you should be knowing linear inequation in X and Y. Okay, so if I say linear equation in X and Y, how does it look like? See, a linear equation in X and Y will look like AX plus BY equal to C. This is linear equation in X and Y. AX plus BY equals to C. And you know, a linear equation represents a straight line. If drawn on the graph paper, it will represent a straight line. Now, how does a linear inequation look like? Very simple. See, if I'm writing AX plus BY greater than C, it is a linear inequation in X and Y. If I'm writing AX plus BY lesser than C, this is also linear inequation in X and Y. If I'm writing AX plus BY greater than or equal to C, this is also linear inequation in X and Y. If I write AX plus BY lesser than or equal to C, this is also linear inequation in X and Y. Now, what is important, students? See, here I wrote, just keep listening. Here you saw, here I wrote that a linear equation in X and Y will represent a straight line. It will represent a straight line on 2D plane, that is on XY plane. So the question here is that what will a linear inequation represent on XY plane? What will this represent? Now for that, I will give you an illustration, okay? So let me start with an illustration for you. See here, I plot for you XY plane. Okay, now on this XY plane, you have the X-axis and Y-axis. Now, you know, somewhere you will have numbers, positive numbers on the right side of X-axis. And here you have negative numbers. This side you have positive numbers on Y-axis. And this side down you have negative numbers on Y-axis. Okay, so suppose students that if I plot a line, okay, and the line here I plot is, say, I have a line 2x minus 3y equals to 6. So what is this line? See, this line is, take that 3y on the other side. So you have 3y equals to 2x minus 6. What do you have? You have 3y equals to, see, I'm taking 3y on one side. So I'm getting 3y equal to 2x. 3y goes on that side, so positive. 6 comes on this side, so negative. 2x minus 6. Now I divide by 3, so I get y equals to 2 upon 3x minus 2. So basically this is y equals to 2 upon 3x plus minus 2. So now this line, which was in general form, the equation of the line, see, this is equation in x and y. It's a linear equation in x and y, and this linear equation is in general form. It represents a straight line. Now, in order to get that straight line properly, see, I got it in y equal to mx plus c form. The same line I'm writing in this form. This is y equals to mx plus c, and the y-intercept is minus 2. And what is the slope? Slope is 2 by 3. The positive slope, and then you see this. So minus 2 is here. The line is intersecting the y-axis at this point, negative 2. Its y-intercept is negative 2. Okay? And the y-intercept is negative 2, and the slope is 2 by 3. So 2 by 3 is less than 1. So the line is somewhat like this. See, the line is somewhat like this. See, this is how the line is. You see this? So this is the straight line. And what is its equation? Its equation is 2x minus 3y equal to 6. Please understand. So, my dear students, what did I do? I plotted, what did I do here? I plotted a line. I have plotted a line here. What is that line? The line is 2x minus 3y equal to 6. So, it is very much clear that it's very much clear that any line which is, any equation which is in two variables x and y and it is linear, it will represent a straight line. So once again, see here. Once again, if I ask you that this equation, which equation? 2x minus 3y, if I ask you that this equation 2x minus 3y equal to 6, what does it represent? Your answer will be, it represents the straight line which you see on the screen. Okay? Once again, my question is that what does this equation represent? Your answer is, this equation represents this straight line. This straight line. This equation represents infinite points which are here. Where? Here. See. This equation represents these infinite points. You take any point on this line, you take any point on this line, it will have some x, it will have some y, and the x, y coordinate of all these points will satisfy this equation. That is, 2 times of this x minus 3 times of this y will be equal to 6. Always. Always. So, any linear equation represents a line on 2D plane. Very good. Now I take you to the next step. See here. If I ask you, what does 2x minus 3y greater than 6 represent? greater than or equal to 6 represent. See here. Now when I'm, again watch this, I'm taking 2x minus 3y equal to 6, and in that I'm also writing equal to. So now this inequation, see, first of all, this is equation, please. This is equation, and this is inequation. Now in this inequation, you have two disjoint sets. One is 2x minus 3y greater than 6, and the another is 2x minus 3y equal to 6. So please understand that this one, you already know what does it represent. It represents the set of points which are on the line. This represents set of points which are on the line because it's a linear equation. Now the question is that what will this represent? What will this represent? See students, in a 2D plane, understand this, that in a 2D plane, whenever you draw a line, in a 2D plane, whenever you draw a line, the line goes to infinity on both the ends, it goes to infinity. Now what happens, this line will divide the plane. This line will divide the plane of xy. See this plane. This plane is divided by the line in three disjoint sets. Three disjoint sets or three regions. It is divided in three regions. See, what are those three regions? Those three regions are three regions. Those three regions are, number one, the line itself. The line itself. What did I say? I said that whenever you draw a line on a 2D plane, the line divides the whole 2D plane in three regions. Number one, the line itself. Number two and number three are the half planes. Okay? One half plane, and here second half plane. Second half plane. Now what are these? I'll tell you. See, when you drew the line 2x minus 3y equal to 6, when you drew the line, what happened? The line gives us total three regions. One is the line itself. One is the line itself. See, it gives us total three disjoint regions. Disjoint. What is meaning of disjoints? No overlapping. So see, one region is all the points on the line itself, and then the other regions are half planes. See students, I'm talking about this. I'm talking about these half planes. See, this. See, this is one half plane. You can say above the line. This is one half plane above the line. And the next is this half plane. See the second half plane. It should not touch the line because line is a different set of points. See, this half plane. I hope you followed it. So, what did I teach you just now? I taught you that any line will divide the XY plane in three regions. One is the line itself, and two regions are two half planes. Now see, by half plane, you should not think it is exactly half. No, not like that. This is the way we call it, okay? So when I have here 2x minus 3y greater than 6, sorry, when I have here 2x minus 3y greater than or equal to 6, remember in this we have two regions. One is the line itself and the other is one of the half plane. One region is the set of points on the line itself. One region is the set of points on the line itself. And second is one of the half plane. You know that this line will divide the region into two half planes. We have one of the half plane with us. Now to decide it, see what I will do. I have drawn the line for you. Now this 2x minus 3y equal to 6, you just have it here on the screen. Now the question here is that this inequation, it represents which half plane? Whether it is this half plane, this side half plane, or it is this side half plane. Which half plane it is? I'm sorry, it should not go that side. Or it is this side half plane. Which side half plane it is? So my dear students, it's very simple to find it out. You know what? We will take a point. We will take a point from one of the half plane and substitute in this inequation. If the point satisfies the inequation, we can say that the region in which the point lies being represented by this inequation. Okay. So see here, how do I do it? I will write, see, so this is, I'm checking for this half plane. Okay. So what I will do, I will select the easiest of all points, that is 0, 0. See, 0, 0 is lying in this half plane. So see, I write here, put x equals to 0 and y equals to 0 in this inequation. Okay. So see, 2 into 0 minus 3 into 0 is greater than 6. This is the inequation, right? So what do I have? I have 0, 2 into 0 is 0, 3 into 0 is 0, 0 minus 0 is 0, 0 greater than 6. Now tell me, is this true? Is this true? No, this is not true. What does it mean? It means that this point 0, 0, the origin, the coordinates of origin are not satisfying this inequation. It means the region, REGION, the region in which origin lies is not represented by this inequation. Okay, so this region, you know, where the origin is lying, it is known as origin side. It is known as the origin side of the line. It is known as the origin side of the line. Why? Because the origin contained in this side. So I will write here that this, okay, I write, is this true? I'm sorry, I asked you, is this true? No, this is false. This is false. So I will write, therefore, 0, 0 does not satisfy. It does not satisfy. It does not satisfy 2x minus 3y greater than 6. Okay. So I will write, therefore, 2x minus 3y greater than 6, okay, represents the non-origin side of the represents the non-origin side of line. Okay. So what will be the solution set for this? What will be the solution set for this? See, this has got line, this has got line as well as this half region. So it will be this, see here. It will be this non-origin side. So, and this time, I'm touching the line. Why am I touching the line? Because I have got the half region along with the line. So the solution set is this. This is the solution set. So here, students, if think the line given to us was, if the line given to us was, say, it was say 2x minus 3y lesser than or equal to 6. In that case, what would have been, I'm sorry, 2x minus 3y lesser than 6. In that case, see here, I'm not writing equal to. So if I'm not writing equal to, you understand that line 2x minus 3y equal to 6 wouldn't come. It will only be the half plane. So if I ask you, what is this half plane? Please understand that if you have to go for one inequation in which equal to sign is missing, see, this is missing. You see this? That equal to sign is not there. It is not there. Still, in order to get this, even though that equal to sign is not there, in order to get the region represented by this, in order to get the half plane represented by this, you will have to go for the line first. You will have to first draw the line. Which line? 2x minus 3y equal to 6. You will draw the line. Yes. After you will have drawn the line, I will teach you how to draw the line also. After you will have drawn the line, now you know that this line basically is not there. So what would you do? Then, see, I'll tell you what would you do. You will first draw the line, and then since you will draw the line, and then since you have only 2x minus 3y lesser than 6, that line you will make it dotted. You will see, you will do this dotted thing. You will, why? Because the line is not there. You will do this dotted part. You will do this dotted part like this. Because we don't have to take the points on the line. We just have to take the half region. So this dotted thing you will do, you will make dot. Okay, you are making the line, but you are making it incomplete. What does it represent? It represents that the line is not to be included. And then you want the half plane. So see, how do I get the half plane? The half plane will be this side. You see this? So you will now go for this side. See, this is the solution set of this inequation, which this inequation. What does it represent? It represents the half plane, which is containing the origin. Now, if you ask me, so how you know this one? You did not even check it. See, I know it because just now I had checked the other one. If greater than 6, if 2x minus 3y greater than 6 is this side, definitely less than 6 will be this side. Okay. So students, now you know you can have many such questions for solving, and it's going to be actually easy. This is very easy part. LPP is actually a very easy topic. Those students who have idea of those who students who have idea of straight lines and inequation, they all find this particular topic much easier. You just don't have to worry about the topic. So students, let us begin with the explanation here. See, these all things are the same thing which I just explained you. Okay, so what I will do is, instead of wasting time here, I will take you directly. Yeah, we do have to learn the meaning of convex set. Yes, this convex set I do have to teach you. I will definitely do that. And then we have to know what is convex polygon. Okay, that we have to do. And I think it is time I directly take you to the exercise. So here is 7.1. See, in 7.1, there are five, five problems. And what I will do is, from each one, I will solve one problem. Okay? Let me start solving one by one. I told you, students, it's going to be very, very, very easy. So you shouldn't actually be worried about this topic. Okay, as such, the questions that we are solving now, it is not going to be asked in exam also, but still I'm doing because just to make you feel good about it and understand. We are doing everything right from the scratch. So here, see, they say solve graphically. Now, what is meaning of solving graphically? You have to give the solution set. Okay, so please let me write that also. There shouldn't be any doubt with regard to any of the statement. There shouldn't be any doubt with regard to any statement in this topic. So here I will write solving graphically, solving graphically solving any inequation inequation graphically means giving the set of points giving the set of points by giving I meant plotting, you know plotting plotting the set of points which will satisfy the inequation okay. This is what we have to do, students. So let's begin with the first question. See, the first question is x greater than equal to 0. See, in x greater than c, first of all, you draw x-axis and y. This is y-axis, this is x-axis, this is origin. They are saying x greater than or equal to 0. What I have in this, I have x greater than 0 and I have x equal to 0. What is x equals to 0? The y-axis. The y-axis is x equal to 0. See, this is y-axis, my dear students. So the solution set is y-axis. What more? And x greater than 0. Which side is x greater than 0, my dear students? It is the right side. This all points are x greater than 0. X0 on y-axis and x greater than 0 is the right hand side of y-axis. It is the right hand side of y-axis. Okay, this is how it is. This is how it is. This is how it is. So what is the solution set, my dear student, for the first question? See, this is the solution set. This is the solution set. I hope it's clear to you all. Same way you can do the second, third, and fourth on your own. I solved this for you. You can do second, third, and fourth on your own. Okay? Next. Now I go for the second question. See, what is the second question? They're saying solve graphically. Now this time, they are giving us two inequations simultaneously. So what I have to do, students, I have to go for the intersection of points. Try to understand. This time we have to solve graphically x greater than equal to 0. We have to solve graphically x greater than equal to 0 and y greater than equal to 0. So see, how do I do it? First of all, I'll go for the x, I'll go for the coordinate axis, that is y axis and x axis. This is y axis, this is x axis, this is origin. Okay. Now see, there are two inequations that I have. Please understand that in the previous question, I had only one of them, but this time I have two. Okay. So first of all, what I'll do is, see, I'll go for the first one. What is the first one? See, the first one is x greater than or equal to 0. I know, which is x equal to 0 and x greater than 0. X equal to 0 and x greater than 0. So where is that? Please understand. X equal to 0 and x greater than 0 is this. It is this. X equal to 0 is this. X equals to 0 is y-axis and greater than 0 is this side. And greater than 0 is this side, it is this side. It is this side. This is how it is. What is this? This is x greater than 0 and x equal to 0. Is this over? No. They don't want, see what they have given. They are saying and. You know what? They want those set of points which are satisfying this condition and this condition, both the conditions simultaneously. So I have still got only x greater than 0 equal to 0. I want y greater than equal to 0. What are those points which are y greater than equal to 0? See, students, those are here. Y equal to 0, it is this set of points, y equal to 0 on x-axis. And y greater than 0 is all the points above x-axis. You see this? These are the points which are y greater than 0. These are the points which are y greater than 0. So, what I have to understand is, in order to solve this, I have got set of points here, where see, these are the set of points which are satisfying both the conditions. See, these all set of points which are in first quadrant. You see this? The set of points which are in first quadrant, they are simultaneously satisfying both the conditions. Why? Because see, these all points that you have in the first quadrant, for them, x is greater than 0 as well as y is greater than 0. Okay? Along with the y-axis and x-axis, that positive of y and positive of x. Because on the positive of y, you have x equal to 0. On positive of x, you have y equal to 0. See, if I take a point here, what is problem with this point? This point, for this point, x is less than 0, which is not the condition. The condition is x should be greater than 0. If I'm taking a point here x is proper, but y becomes lesser than 0. I don't want y less than 0. I wanted what? I wanted y also greater than 0. So I understood how is it, students? So I solved one for you. See, I solved one for you. What you will do? I solved one for you. You will solve the rest. Okay. But then now I tell you the technique by which you should be going. You don't have to go by this technique. This was just for the sake of making you more comfortable. When you see something visual with proper shading and all, you get the proper idea about it. But see, you don't have to solve it this way. How should you do it? I tell you, very simple. First you write this in equation. What is it? It is x greater than equal to 0. So in this inequation, what is the equation? The equation is x equal to 0 and the inequation part is x greater than 0. See, what you should do. Go to the line always. Go to the line always. Go to the line always. What is the line? Y-axis. What is the line? Y-axis. Go to the line. Okay, I went to the line. Now what I will do, once I reach the line, I have reached the x equals to 0. What do I want? I want x greater than 0. So I will now use a very faint pencil, very light. I want x greater than 0. Yes. So I will put a cross. I will put cross with a pencil, a light pencil. I will put a cross. Why? I don't have to go this side. X greater than 0. It means this side I don't have to come. All these are x less than 0. Excellent. Now I will go for, see, I will go for the next. That is, I'll go for the next. That is this inequation. Okay. So what it is? It is y greater than or equal to 0. What is the equation? Y equal to 0. What is the inequation? Y greater than 0. What will I do? I'll draw the line first, line first, line first, line first. What is the line? The line is y equal to 0. Draw it. This is line y equal to 0. This is the line y equal to 0. Fantastic. Now what I will do? I want y greater than 0. Since I want y greater than 0, I will strike these this side. Why? Because all this side is y lesser than 0. Now, whichever side of the line you have this marking, you don't have to go to that side. So see, the solution set, you know what? It is now very clear that this is the solution set. It is very much clear. See, this side no, line yes, and this side yes. I hope you all followed this. So students, see, the way I did it, you will also do the same way. See, this is the side. And it is unbounded. It is unbounded. There is no boundary to it. There is no boundary to it. Unbounded solution set it is. This way you have to draw the solution set. And what about these strikings that you did, with the help of eraser? Just remove them all with the help of eraser. Once again, remove. And when you will remove, you will get a nice looking solution set solved graphically. I hope you all followed it. So students, as I solved this problem for you, the first one, the remaining second, third, and fourth, you can do on your own. Okay. Now I take you to the next question, and that is question number 3. See, what is question number 3? Question number 3 is solve graphically. What is the difference between this third question and the questions that we solved earlier? See, very simple. You notice that, the first question you have, it was x greater than equal to 0, y greater than equal to 0, x lesser than or equal to 0, y lesser than or equal to 0. So those inequations, they were of the type, they involved the x-axis and y-axis as the line. They involved x-axis and y-axis as the line. Whereas in question number 3, we are going to have lines other than x-axis and y-axis. Yes, you heard me right. This is y-axis, this is x-axis, and we are going to have the lines other than x and y-axis. See, this is y-axis and x-axis, y-axis, x-axis. This is origin. See, I solved the first problem here. What do they say? They say that solve graphically. You know the meaning of solving graphically. You have to plot the solution set on the graph paper. Okay. Graph paper does not mean the actual graph paper. You can always draw. You can use the ruler, draw x-axis, y-axis, and do it. So here, see, I'm solving question number 1. What does it say? It says 2x minus 3 greater than or equal to 0. That is 2x. I add both sides 3. So the sign of inequality does not change. 2x is greater than or equal to 3. I divide both sides by x. So x is greater than or equal to 3 by 2. Now, once again, students, you notice that in this you have got a line and an equation. Okay. So the line here is x equals to 3 by 2 and the inequation part is x greater than 3 by 2. Okay. What I will do, I will first plot the line x equals to 3 by 2. This line is in the form x equals to k. Every line which is in the form x equals to k, any equation which is in the form x equals to k, it represents a line which is parallel to y-axis. See, this is x equals to 3 by 2. Now, 3 by 2 is somewhere 1.5. So I take here 1, this is 1, this is 2. So this is what? 1.5. This is 3 by 2. That is 1.5. This is 1. This is 2. This is 3 by 2. 1.5. And so on. So when you drew the line, basically you drew all the points which are being satisfied by this equation. So see, as I told you, students, any inequation represents, any such inequation will represent two solution sets. One is the line itself and the another is the half region. Now see, x greater than 3 by 2. Tell me, students, what do you think? See, one is the line. Now, which half you think is x greater than 3 by 2? It is definitely the one which is on the right side of this x equals to 3 by 2. And it should touch the line because x equals to 3 by 2 is also given. So see, this is the solution set of what you just had. See, this is the solution set. It is what? X greater than or equal to 3 by 2, or you can say 2x minus 3. You can 2x minus 3 greater than or equal to 0. You can say 2x minus 3 greater than or equal to 0. This is the solution set of this inequation. Now, as I solve this, you can solve this, this, and this. Okay, these three you can solve on your own. I hope you followed it. I hope you followed it. Okay, so before solving few more questions, students, let us start. Let us start with some of the theory part that we have to know. So here, students, see, you notice the heading is convex set. Okay, it's a very important concept in LPP. Let us learn what is a convex set. Very important part it is. So I will read a set of points in a plane is said to be a convex set. See, every set is what? Set of points here, please. Every set here is set of points. So what is a convex set? It is a set of points in a plane is said to be a convex set if line segment joining any 2 points in the set entirely lies within the set. Entirely lies within the set. Okay. The following sets are convex sets. So here students see they are giving us an ellipse. See, in order to make you understand, see, I will take 2 points inside this set. Okay, let me take any 2 points in the set. So here I take 1 point, say I call this as P, and then I take another point Q. Now these 2 points belong to this set. Which set? The elliptical set. Okay, fine. These 2 points, P is a point in the set, Q is also a point in the set. Now let me join this with the straight line segment. Now, if I ask you that what about the line segment PQ? You will say that PQ also lies entirely in the given ellipse. This ellipse, my dear students, it is a convex set. It is a convex set. Yes. Why? Because look at the definition. What the definition was. Look at that. It said a set of points in a plane is said to be a convex set if line segment joining any 2 points of the set entirely lies within the set. Okay. Same is the case here. Same is the case here. See, it's a pentagon. Let me take any 2 points in this pentagon. Let me take any 2 points. So here, see, no matter where you take, you can take it very close. So here I take here, see, this is point R. I take it this point as R. Okay. I take this point as R. This is R. I take, and then here, here I take S because I want to check. Now these 2 points belong to the set. Yes. Let me join R with S. What I notice, this segment once again lies within the set. This is also a convex polygon. It's a convex set. I hope it's clear to you all. Now students, please understand that if I go ahead and I have any such set, look at this. These sets, these sets are not polygon sets. I'm sorry, they are not convex sets. This set is not a convex set. Yes, you heard me right. Even this set is not a convex set. You know why? Because look at this set. See, when we call this set, I mean this is a closed polygon. It's a closed polygon. And this set of points, which I'm shading, this set of points which I'm shading, this is not a convex set. Why? Because you can check, we have taken 2 points in this set. We have taken 2 points in the set. And what are those 2 points, my dear students? Those 2 points are A and B. Those 2 points are A and B. Yes. Those 2 points are points A and B. Point A, point B both belong to the set. But when you join point A with the B with the help of a line segment, what do you notice? You notice that there is a part of the line segment which is not inside the set. This part of the line segment is outside the set. Hence, such a set is not a convex set. Same is the case here. When you see this set, look at this set. It is this set, you have a point B inside, you have point A inside, but when you join A with B, with the help of a line segment, see this part of the line segment, it is not inside. It is not inside the set. It is not lying entirely in the set. So it is not a convex polygon set. It is not a convex set. See further. There are notes It says the convex set may be bounded like this. You can check. See, this is a convex set and it is bounded. Then here you have a convex set. It is bounded. That's what is written. Following are bounded convex set. Further, it says convex sets may be unbounded. Okay, you can check. This is a convex set here and it is unbounded. You know what? This set we are talking about. This is a convex set and it is an unbounded convex set. Okay. This is a convex set and it is unbounded. Okay. This set is convex. Yes. I'm going in the direction of arrows from the line. Okay, I'm going in the direction of arrows from the line. This set is a convex set, but it is unbounded. Why is it convex? For the simple reason, if I take a point anywhere in the set, another point anywhere in the set, join these 2 points with the help of a line, the line entirely lies in the set. So it is unbounded convex set. Same is the case here with the parabola. This is also an unbounded set. You see this? It is open on one side. It is open on one side. See, a parabola, the branches of parabolas goes to infinity. It goes to infinity. This is also unbounded. There is no boundary. It is not. What is the bounded set? Which has boundary from all the sides. It has boundary from all the sides. Further, it is the same thing which I just taught you. Graphical representation. I just taught you what is it, and this is all very simple. Let's go once again to the problem solving. So students, now we are going for question number 4. In question number 4, what we have, so far, whatever problems you have solved, my dear students, in all those questions, you had the linear inequation, but the number of variables you had was just 1. For the first time, you have the number of variables too. See, x and y both are there. You see this, x and y both. Here also, here also, here also. Earlier to this, what happened? You had the inequation where the number of variables was just 1. So see, because the number of variable was just 1 here, see, this only in x. So what happened? You got the line parallel to y-axis. Here you will get the line parallel to x-axis. Why? Because it is 2i, 2y. It is 2y minus 5 greater than equal to 0. So in the next step, you will write 2y greater than equal to 5. So next you will write 2y equal to 5, the equation, and 2y greater than 5, the inequation. Got that? I'm sorry. In the next step, you will write y greater than or equal to 5 by 2. So y greater than 5 by 2 is 1 inequation. You know y equals to 5 by 2. So y equals to, see, just one variable. It is what? Y equals to 5 by 2 is a line parallel to x-axis. This is y equals to 5 by 2. You will write the line, and then you got this. You got the solution set of the line, which is this. Now what do you want? You want the solution set of y greater than 5 by 2. What are those? Those are these points, So you will start with 5 by 2 and you will go on. What I just wanted to say is all these problems you had just one variable, but in question number 4, look at this. In question number 4, where you have to solve graphically, the number of variables you have is not 1. It is 2 variables you have got. You have got total 2 variables. You see this? So what I will do is I will solve a problem for you all. So let me start with question number. Okay, I solve for you question number 2. Okay, I will take the second question. What it is 2x minus 5y greater than or equal to 10. So as I said, students, earlier, in this, you will have one inequation and one equation, right? So what's the inequation part? The inequation part is 2x minus 5y greater than 10. And what is the equation part? The equation part is 2x minus 5y equal to 2x minus 5y equal to 10. Okay. Now see, students, when you have 2x minus 5y equal to 10, this is a line. Every time you have to draw the line first. Yes. First you draw the line, then only the line will decide this half, this. So much so that if in some question you notice that there is no line, this equal to is missing, just check. Equal to is missing, just check. Equal to is missing. Still, what you will do, you will have to go for the line. The only thing is the line that you draw is going to be the dotted line. So see, 2x minus 5y is 10. I will get the line. So how do I get the line? The best thing is you will find the x and y instead. I put y equals to 0 in this line. So when I put y at 0, what do I get? I get 2x equals to 10. So x equals to 5. It means 5 comma 0 is a point on the line. Point on the line. You can say 5 comma 0 is a point on the line, or you can simply say the x-intercept of the line is 5. Okay. The line cut the x-axis at 5. Now what I do, I'll put x equals to 0. I'll put x equals to 0. When I put x 0, I get minus 5y is 10, and this gets me y equals to minus 2. So I get 0 comma minus 2 is a point on the line. It is a point on the line. Now it is time I drew the line. Okay, so now I will draw the line. So here, what do I do? See, I go for the y-axis, I go for the x-axis, and then I want to draw the line. So this is y-axis, x-axis, this is origin, the negative of x, negative of y. See, I want 5, 0. It has to be all. See, you will have a scale with you. You can use a scale. I'm doing without scale, so mine could be slightly off the shape and scale, but then you can do it. You will take 1 centimeter as 1 unit on your answer booklet. So 1, 2, 3, 4, 5. See, here I have got 5 comma 0. This point is 5 comma 0. And then I have to have 0 minus 2, which is on y-axis. So see, this is 1, this is negative 1, and this is negative 2. This is, now what I will do? I will join these points, I will join these points. Yes. So see, when I join these points, this is the line I'm getting. See, I join these points. This is the line I'm getting. No need to go so far. This is the line that I get. So students, now you can check I got the line here. What is this line? This line is 2x. Okay. See, this line is 2x minus, you write the equation of the line immediately beside it. 2x minus 5y is equal to 0. So after having drawn the line, you have managed to get the solution set of this equation. Yes, this line itself is the set of points representing this equation. Now we have to go for one of the half plane. What's the idea? The idea is very simple. I will take one point from one of the half planes. So I go for the origin, which is 0, 0. Is 0, 0 going to satisfy this? Check. I will write here. Put x0 and y0 in above in equation. Is it going to satisfy? Definitely not. The 0, 2 into 0 is 0, minus 0 is 0, 0 greater than 10, which is false. I write here, which is false. If it is false, what does it mean? It means that x0 and y0 do not satisfy this inequation. Hence, the origin does not lie in the region. It does not lie in the region being represented by this inequation. So, what is the solution set? It is the non-origin side. This does not the half plane which this contains, the half plane which this represents, does not contain the origin. So the solution set is going to be non-origin side, and hence it is this way. See, it is this way, the non-origin side. I hope you all followed it, how to do it. So this you can always do. This is how it is. This is the graphical solution set of the given equation. I hope you all followed it, students. Yes, this is the answer. The only thing, I see the write-up that you see. Uh, yeah, the write-up should have been in such a way that it does not overlap the diagram. So you just try to maintain the distinction, write the write-up separately, and the diagram has to be separately drawn. Thank you. Students, as I have solved this question number 2 for you, what you can do is you can solve question number 1, 3, and 4 on your own. I'm sure you will all do it. Thank you once again.